everyone. In this video, we will see half-wave and full-wave precision rectifier experiment. So the precision rectifier is a configuration obtained with the operational amplifier in order to have a circuit behave like an ideal diode and rectifier. So in a typical rectifier circuit, we use diodes to rectify AC to DC. But this rectification method can only be used if the input voltage is greater than the forward voltage of the diode. To overcome this issue, precision rectifiers were introduced. In precision rectifier, we use op-amp to compensate the forward voltage drop across the diode. This is the circuit diagram of the half-wave precision rectifier, where one half of the input cycle produces the partial DC. And this is the circuit diagram of the full wave precision rectifier, where the entire input cycle produces the partial DC. Now we will check out how the connections are given in the lab.
Now we are going to see half-wave rectifier. Half-wave rectifier is a very simple circuit. I have connected my IC as the first pin appears here, 2, 3, 4, 5, 6, 7, 8. Bottom I have connected 1, 2, 3, 4, 5, 6, 7, 8. This is my pin configuration of IC741. Like that I have connected. So one diode in an anode cathode position from the 6th pin, output pin of an 741 to some other point. One point I have connected it. From that point I have connected one resistor to the ground. From the diode end to the ground, one resistor I have connected. The resistor value is 10 kilo ohm, and I have connected the feedback, just a feedback, no resistance between. So from 2 to 6 I have connected one wire from the inverting terminal to the output pin of an 741, and I am giving the input to third pin, that is non-inverting terminal of an IC. I have generated a waveform in DSO. That input I have given to the third pin of an IC. Here I have connected two positives, the wavegen output and the channel 1 probe. Positive I have connected, that is my input that I have given to the third pin of an IC, and this is my second channel probe. Second channel probe I have given to the diode end. This is my output, diode end. I have given the positive and negative to the ground, and we have given the supply plus 12 volt to the 7th pin of an IC and minus 12 volt to the 4th pin of an IC. So this is our input, and input I have set it 1 kHz frequency and amplitude is 4 volt, and if you see the output, the peak to peak is around 2 volt, that is it is half rectified. I have set it 4 volt and we got only 2 volt and it is half rectified. This is our output. Now we are going to see full wave rectifier. Full wave rectifier is a little complicated circuit. As per our circuit diagram, I have given the two ICs, and first I have given the plus 12 volt to the 7th pin of second IC. From there I have taken a loop, that loop connecting to a 7th pin of an first IC. So the positive for an IC we have given, then the negative voltage I have given first to the second IC 4th pin. From there I have taken the loop that I have connected to the 4th pin of an first IC. Okay, then from second pin of first IC one resistor is coming, that resistor goes to one end. From that end one more PN diode is connected, that is going to the 6th pin of an first IC, and from the same 6th pin of an IC one more diode is connecting and it goes to the other end, not to the resistor, it is going to some other end, and from that end one more resistor is going to the second pin of an IC. This is a loop, one resistor coming from the IC1, from that end one diode is going to the 6th pin of an IC, and from that 6th pin one more diode is connected to one more point. From that point one resistor is connected again to a second pin. Okay, so totally 3 resistors are there in second pin of first IC. two resistors we have connected, and one more resistor from the second pin we have to connect to some other point, that is for giving input. Okay, now we can see the second IC. Second IC 2 to 6, the feedback resistance is connected. Feedback resistance 10 kilo ohm is connected from 2 to 6. Then the third pin of second IC is connected to the end of an second diode. Where the second diode ends, there we have to connect the second 741 to that point. And the first IC third point is connected to the ground. The first IC third point is connected to the ground. Now all connections are given, and we have to give input and we have to take the output. I have given input to the resistance ends. As I told, from the second pin one resistance is given, and for that end I have given the input, and the ground of that given to ground, and second channel positive I have given to the sixth pin of second IC, that is our output, and ground to the ground. Now we can see how the circuit. This is our output of an full wave rectifier. I have given input as 4 volt. We have given in a half wave, right? So the same voltage I have given, 4 volt input I have given. I got only 2 volt output. So it is rectified, and only in full wave only positive half cycles will be there. In half wave only we will get the positive half cycle of 1, and the negative, for our negative half cycle we will get a blank 0 line. Here full positive half cycle we will get for each waveform. This is the output of an full wave rectifier.